Hi, and welcome to Chapter 2 for Psych 150. Again, we're going to go through a PowerPoint here and try to do it fairly efficiently. If there's more questions, please feel free to send a message via Remind or email. I'll be happy to expand on it. If enough people ask questions about a topic, I'll be happy to put together a little video for you or a Zoom call. Okay, so let's go ahead and get into the video. Last one was really high level, talking about different types of psychology there, introduction to it. This is about the research. The research is so important, especially in today's society of fake everything. There are truths, there are facts, but they have to be founded in research, not anecdotal information. So what you'll hear me say, hopefully a couple times in this video, is because you have an opinion does not mean that's a truth, doesn't mean that it's researched. Many times I express someone and somebody says, well, I know a guy who, and it's contrary to what the research says, but research usually says something is valid within 90-95% of the time. There's always exceptions, okay? And that's valid research. It's research done by a group that has no biases involved with it. Many times research is done by groups that are paid for by the group that wants to prove something. And that's not research, that is marketing. Okay, so anyway, let's get into it and we'll go from there. Okay, so again, I mentioned a little about why it's important. And proper research is important because it allows us to really see the truth involved with something rather than just somebody's opinion about it. Okay, so you can get into that a little bit. By the way, the skull there is what they used to do. If you had trouble with your personality, they would cut a hole in your brain, hole in your skull, and remove your frontal lobe. That was called lobotomy. Okay, that's what that is right there. We don't do that anymore, hopefully. I don't think we do. Anyway, research information is important. This was a major campaign that occurred a while ago, and very successful campaign. But part of it was that this campaign didn't necessarily research, didn't show any research that was associated with it. And so it was just a good marketing effort. It wasn't necessarily researched information. And think about this. What is the expertise of someone making the claim? What is their role? A politician making a claim about something, especially with polls and stuff like that, you kind of need to assume that person has a bias. Okay, so we'll get into that a little bit, the types of biases that are out there. What might they gain to claim is valid? For example, a group of dairy cows, not dairy cows, but farmers, ranchers from dairy cows, got together and gave some money to an organization to research milk and show that it was good. Okay, so they gave the money to the research company. They went and researched it. They came back and said milk's good, and they came out with this claim that milk is good. They had to gain that they were sold more milk. Okay, that happens all the time. And so you need to really look and see who is paying for the research. Okay, the claim is justified, and what do other people think of it? Is it replicable? Are there several groups and organizations that do the exact same research and get the same result? That's what's real important. Okay, so this is kind of scientific method process. But you have a hypothesis. You go to inductive reasoning, which means you go through the process of gathering data, you come up with some empirical observations from that data, and you created a deductive reasoning, which means you deduce the answer from the data, and that creates your hypothesis. This cycle keeps going round and round. It doesn't just stop somewhere. Okay, come up with a piece of data, and then they go back, oh, okay, what about this? And they go back and work through it again. That's what scientists do. Okay, that's why science is so important. Good science, proper science. Okay, so not all science by any means. There are people around that still think the Earth is flat, and that's interesting perspective. But as you can probably gauge, I don't necessarily buy into that. Here's a scientific method. Okay, most of you have been through that. Okay, it goes through this process of you create a theory, create a hypothesis. Hypothesis is usually a question. The question usually is that, or statement that X milk is good for your body. Okay, there's research, there's observations that go back, and they put the information together. And they create a theory. Yes, milk's good for your body, and if it's a good scientific work, it goes round and round, as I said before. So anyway. Falsifiable hypothesis. So this is the Freudian stuff. This is why Freud isn't really of value too much anymore, except that he was one of the first ones to create a scientific process for psychology. Here's the id, ego, and superego. Ego is what works between the two. The id is the devil. Superego is the angel. Those sit on your shoulders, and the ego makes the difference. This is all in your subconscious, unconscious. This is in your preconscious right here, which is like what's floating on your tip of your tongue kind of stuff. And this is what's occurring in terms of behavior, okay, or conscious areas, or thoughts that come out that are real, okay? You couldn't disprove what Freud was saying, so it wasn't falsifiable, okay? So therefore, you should be able to disprove something and say, nope, this is, if I do this, this, and this, it's not true. If I do this, this, and this, it is true, and you should be able to handle both sides of that going forward. If you can't do the not true, then you've got to wonder whether it's actually true in itself. And we go more on that later. Different types of studies: clinical case, naturalistic, surveys, archival, and longitudinal cross-sectional. This is an important video we'll watch later. You know I'm watching now. This is Judy the Wild Child. This was a case study. This was one person that they found until age 13. They weren't able to leave a room that was dark. They were strapped all day long on a potty chair, and at night they were put into a cage. Only the dad came in, and she never learned language. And so there were studies about language development in 13-year-old at that point. That is what's called a clinical or case study. That's one person, and they try to take that and say, does that match now the larger population? Sometimes yes, and sometimes no. Okay, so additional studies are needed, but this helps create that hypothesis. Naturalistic, watching things in natural behavior. Okay, watching things that go on. One of the big biases is observer. If you are a police union, let me just say this, and you are trying to determine whether your officers behave properly, you have an observer bias. Your idea is you want to teach them to behave. You want to show that they behave properly. The opposite may be true as well. So you have other things that go on, and a person believes something shouldn't be that way, and they tend to find information that validates that. Okay, more about that later. This is Jane Goodall and the chimps. Most of you probably heard the stories of those chimps, but she went and watched the chimps in the wild. She didn't interfere with them. She watched them from a distance and recorded the information. That's naturalistic. Okay. Watching riots or protests or marches from a distance and doing research on them, that's naturalistic observations. Not getting in the middle of it, but being part of it, okay? That becomes observer bias. Surveys. Surveys are good for just kind of a quick idea. They're usually not real accurate, and they're very difficult to put together properly. Questions properly that don't lead someone to a correct answer. Generally, they're not used in really scientific studies. The surveys you find on websites, on Facebook, in Twitter, those are not studies. Those are just surveys for someone to try to prove an opinion, okay? So that was not what I would call research, but there are some that are out there that are valid surveys, okay? Archival research is when you go back and you go back and look at the records. And so you go back and look at smoking, for example. If someone is a smoker, then you go back and look at their research to say what has changed in their body from all these years of smoking, and that will come back and say smoking does X, Y, and Z. Okay. Longitudinal, another example of a study where you actually start today and you start tracking something for a long period of time. So longitudinal means that I take one person and I follow them along, or a group of people. I follow them along for a period of time and watch the research. A cross-sectional is I take one point of time and I survey or I study a whole bunch of different people, different ages, and then I make the assumption in terms of development and development stages. Okay, so cross-sectional is what is in a period of time, single period of time it says here, and longitudinal is over extended period of time, usually watching a single person or a group. Okay, attrition is something that's a problem where people drop out over that time, and you may start with 100 people in a study, and 10 years later you've only got 7 left. And does that become a valid study at that point? Okay. Maybe, maybe not. Correlation versus causation and experimental research. So let's talk about that real quickly. That's another key element. So correlation. Correlation is does something approximate? Is there a correlation? Is there something that works between the two? Height and weight. Generally, the taller somebody is, generally the more they're going to weigh. Okay. Not always. You can find a 7-footer that weighs 180 pounds, and you can find a 6-foot person that weighs 280 pounds. So not always, but there's data that shows that generally when someone gets taller, their weight is going to go up, not in a straight line, but in somewhere in this data points. Hours of sleep. The more hours of sleep you have, the less tiredness you have. Okay. Actually, more tiredness you have, the more sleep you have. So basically what it is if you have sleep, you'll be tired less. Okay. There's a correlation between sleep and being tired, number of sleep. Hours of sleep and exercise, scatter plot. There's no correlation between the two of them. Okay. Now it seems obvious, but that's just one way to look at it. A positive correlation goes up on the right. Okay. A negative correlation goes down on the right. So positive up, right. Negative down, right. Negative down, positive up. Okay, that helps you kind of understand those a little bit. Okay, causation and correlation. Okay, so here's something that's interesting. Crime rate goes up when ice cream sales goes up. Is that a correlation or is that a causation? Do ice cream sales cause crime rates? Do crime rates cause ice cream sales? Answer for most of us from a logical sense would be no. Okay. There is a correlation in terms of that, just like swimming pool activity would go up in the summer, okay? The confounding variable here is that when temperature goes up, crime goes up. When temperature goes down, crime goes down. Ice cream sales goes up, temperature goes up, and goes down when it goes down. So there's a confounding effect which affects both of them, but it looks like if someone could say, for example, when people say cancer drug use, okay, there might be caffeine causes cancer, okay? They might say causes. There might be a correlation between the more caffeine you drink and then more breast cancer you get, okay? Now the causation could be something very different. It could be stress oriented, it could be cortisol oriented, it could be anything else, any other confounding factor. I'm not saying it does or doesn't solve it right now, but I'm saying there's a correlation between the data, but it doesn't cause one. So you find many headlines that say caffeine causes cancer, and you look in the thing and it talks about correlations, okay? Or the more you exercise, the less your chance you have of breaking your leg. Well, there might be something there. The exercise causes calcium buildup, which causes your bones to increase, but also probably the more you exercise, the more activity you want. So you might actually might break your bones more because you exercise, not because of the exercise so much as the type of exercise you do. Okay. So anyway, that might be really confusing. I'm sorry about that, but that's how my brain works sometimes. So confounding is a different variable. For example, eating breakfast is a good habit. Okay. So you could do research that people that eat breakfast are healthier. Okay. There could be a correlation to that. Causation, maybe not. Does eating these, I don't know what they call them, Choco Crisp, or I don't know what they call them, is this kind of breakfast it's talking about? No, probably if you had added eating healthy really cause someone to be a healthier weight, okay? That could be possible, but eating cereal doesn't necessarily cause that, so that's a breakfast. That's a correlation, not necessarily a causation. So here's other things. So sometimes people have these correlations that really there's no relation between the two, but they see that. Confirmation bias, we talked about earlier, tends to ignore evidence that disproves its beliefs. This is something about what news station do you look at. Okay, so there's a lot of stuff out there, Fox News versus CNN. If you tend to lean towards the conservative side, you're going to watch Fox News, and they're going to give you all the information that supports your ideas and beliefs, including what they're going to call research. CNN is going to do the opposite. They're going to give you all the information. And they could say the exact same thing, but opposite. That doesn't make sense. They could say the opposite thing on the same topic, and they both are talking about it's a fact. Okay? You need to look into it a little bit more. You need to be a critical thinker. You need to understand what the idea is and maybe go do some additional research. Okay? If it's something that's really important to you. But we tend to just believe what the newscaster says, or they're not really newscasters, they're really entertainment people. You tend to believe what they say and say, well, this is true because that's what I believe. Okay, again, confirmation bias. It doesn't necessarily mean it's true because you believe it. Okay. Again, the causality experiments. So these are different experiments that can take place. So I'll give you one here. Watching video games does not lead people to be more violent. No matter what your parents say, no matter what people say, the research shows that there isn't an increased level of violence. Now there is an increased level of aggression. Okay, if you talk about violence and aggression as two different things, aggression could be just you snap back at your mom or dad or your son or daughter because you're busy doing something and you don't do it. That's aggression. Violence means you get up and just beat the crap out of them. Okay, that is the difference. Okay, hopefully you don't do that to your mother or father or son or daughter. Okay, anyway, that's the difference between aggression and violence. And people will take the aggression and say video games cause violence. They really don't. They really don't. And there's a lot of research that kind of confirms that. So here's the different types: experimental group versus control group. Control group is the ones you don't do anything to. Experimental group is ones you give something to. Okay, so they watch videos, violent videos. They don't watch any really videos. They just watch regular stuff, and you do your research and figure out which one's the experimental group. Is there more aggression or violence in the experimental group as there was to the control group? Okay, and we define variables and some other things there too. So these are different biases that are there, and they're kind of straightforward. Experimental biases means that the experimenter kind of knows what the research is supposed to be, and they skew the results of the study. They don't necessarily do it and say, I'm going to change the results, but they look for different things affect their perception. Participant bias is someone who knows what the result's supposed to be, like when you were taking your quizzes, locus control, those kind of things. If you knew which one was which one and you wanted to be one of them, you probably would answer questions a little differently. I can take those quizzes and I can be whatever I want because I kind of know where the questions are going. I know what they're going to ask. That's participant bias. Single blind means that the participants don't know. Double blind means that the participant and the experimenter don't know what the results should be. Placebo is involved in pills, where one's a placebo means that it's nothing. We used to call sugar pills, and the other ones might have some medication in them. Okay, so that's placebo. Independent dependent variables. So this independent variable is what's influenced by the experimenter, and dependent variable is what we measure. Okay, so how we measure. We measure number of violent episodes. Okay, type of program we watch, violent episodes, yes or no. Okay. Participants, it's fairly straightforward, but participants and sample size. There's a lot of statistical analysis that goes into good research, and the sample has to be a certain size. Can they sample 2,000 people in the United States and come up with how people think? Yes, if they do the right random sampling and they do the right statistical analysis, they can do that. They don't have to quiz everybody. So often when somebody doesn't agree with us, but we go back and say, well, they only asked 2,000 people. Well, there are ways. If you're interested in that, take a stat course or take a experimental design course, and you'll see how that can be the case. Not always, but can be the case. So here's random assignment. It's very valuable. You can't do random assignment if you're going to do male, female. You can't do it if you're going to do tall, short. If you do random assignment, it really has to be random. It really has to be random. What are you going to manipulate? You can't manipulate sex or general or gender necessarily. You can manipulate medications, things like that, activities. So there's certain ethical design aspects in there that are involved here that you can't do that. Okay, some of these kind of experiments are called quasi experiments, which means that it's as valid an experiment, but we weren't able to manipulate the value, the variables, and so we express them as best we could. Okay, and many times the relationship, the cause effect can't be determined, but it will many times give us a correlation, and the correlation could have some level of cause and effect. It might be a small, what's called a t-value, but there may be some cause and effect relationship there, but generally not at the level where you can say it is causal. And ethics keeps us from doing things like Gini and other stuff here. We'll talk about in a minute. Another one. This is statistical analysis. If you're really interested in it, most of the time you get to what's called a 95% value, which means that 95% of the time what you're testing will occur. Okay, that's what I was talking about earlier. You can also get to a 2% value or 2.5% value, which is 97.5% of the time. And statistics will bear that out when you start getting involved in all that. Okay, so that's stat, and it's really interesting, but it's mathematically it's a real challenging course. Okay, so when true research is done, it ends up in peer-reviewed articles, which means that people of all different beliefs and all different professions review it and say, yeah, this makes sense, and this is it. And then what they usually do, go back and try to replicate it. If there's a peer-reviewed journal where several people have reviewed it, other scientists, sometimes in the same field, have reviewed it and said, yes, it looks valid in terms of its experimental processes and its statistical analysis. And they go back and say, can I replicate it? Can I do the same experiment over again and get the same result? Not always. And sometimes they'll come back and they'll say, oh, that was because of some confounding issue, and then you have to go back and redo the initial experiment. Okay. This is one of those that years ago we thought that vaccines cause autism. Okay, vaccines are a big issue today, and to get the coronavirus vaccine, there's a lot of mistruths out there about it. One of them I thought was interesting is that Bill Gates has supplanted a microchip in the vaccine, which will allow him to track you. Probably not true. I don't have evidence to say that's not true, but those are the kind of stuff that's out there. But anyway, let's talk about this one here. This one occurred a while ago. A doctor in Europe, actually in the UK, came up with a study that said that children that were given vaccines had a higher rate of autism shortly after that. Okay. Well, then he released a study. It was about 7 or 8 kids that out of a couple hundred kids, but he felt there was enough to say it proves that there's autism developed because of that vaccine. And he published this in different magazines and newspapers and all that. And so there was a big thing, and a lot of people bought into that as autism is caused by vaccines. Okay. Well, it's come to find out that they couldn't replicate the experiment. The fact that we normally start vaccines at the same time autism tends to show itself in that 5 to 7 years old range. What the doctor was actually seeing was that these kids were developing autism whether or not they had the vaccine. Vaccine was given at about the same time, similar to the crime ice cream thing. And there's still a lot of people that still believe that, but there's research that has gone back and said no. Valid research, peer-reviewed research has replicated it, that there is no vaccines do not cause autism. Okay. So we'll talk about some reliability. Can we reproduce it that's reliable and give the same result? Okay. This is different people producing validity. is the measure an accurate measure? What you're saying is true. Okay, so if the measure is true, it's considered a valid experiment. My dog's going crazy right now. So ethics. The IRB, whenever you're going to do a research study at a university or college, you have to go in front of the IRB and you have to present your information, and they come back and say, you're not going to harm any people. And then there's an animal one as well. And so you can go ahead and do it. Some of the research we'll talk about, like the Milgram or the Stanford one, or the Tuskegee one, those involve injuring other people and could not be done today. Okay, hopefully they're not done today, and that's why the fear of vaccines and stuff. There's these boards that are that are taking up the ethics of them, even though there is still a lot of fear of vaccines in general because of some historical issues that have occurred. And so here's one of them, and here's one of the reasons why I think the African American population or the Black population really struggled. These kind of things took place all the time. Okay, what they did is they took a group of African American men and they injected them with syphilis, and they tracked them in going along, and most of them died. Okay, so the syphilis that they're injecting with them killed them. But many of them who didn't die had to live with the things. Some of them had spouses that they shared it with, and there were some kids born with it from that. So it had a major issue. Even though penicillin was available, as this goes here, this was in the late 40s, early 50s. This is not all that long ago. Okay, these things were happening. So these are kind of experiments that occurred on Black people, especially, because there was still a lot of bias and prejudice that occurred, and racism that occurred, that said it's okay to do it on them because they're not full people. Okay, there's when people were still thinking that this is the Blacks didn't have a vote at that point. Women didn't even have the vote at this time, or women did, but not Black women. So anyway, that's a whole other thing. I won't get into that necessarily, but the penicillin Tuskegee experiment, you'll see, and there's a video of that is in Moodle. Okay, there's the ethics involved, the animals. So there's one for that as well. If you do research on animals, like Pavlov did with dogs, or Skinner with rats. Okay, so that's it with this chapter 2. Again, if you have questions, please contact me via Remind or email. I'll be happy to help you. And good luck on your quiz. And I would have this video available when you take your quiz, because there'll be some information from it on your quiz. Okay. Thank you, and have a great rest of your day.